Okay, so here's your farming lesson. Okay, this is one of the things that we went through yesterday. Plants have to have minerals not only to grow, but to function. And they're not the same minerals all the time. Okay? We have beneficial minerals and essential minerals. Okay, now essential minerals is they have to be there or the plant can't grow. Then we've got beneficial minerals that, lots of beneficial minerals that help with the plant's secondary functions, and they just add more nutritional benefit to what's going on. We have negatively charged elements and we have positively charged elements. When God put all this together, this is just a very fascinating organization on how everything is made. But we're just going to deal with plant minerals and plant nutrition at this point. And so what we have is air and water. We've got gases, carbon, hydrogen, oxygen. In our soils, we can have nitrogen coming from our organic matter, phosphorus, potassium, calcium, magnesium, sulfur, sodium, and our trace minerals over here. These all should be in our soils. When we grow a plant, we look at, when we take and analyze what minerals are in our plant, carbon is 45% of my plant's dry matter weight. Now carbon is the base of all your carbohydrates. Okay, your monosaccharides, disaccharides, sugars, pectins, hemicellulose, cellulose, and lignin. All your plant is carbon based. Oxygen 45%, hydrogen is 6%. So just my three gases alone, I'm at 96% of my plant's weight. If I add nitrogen, which I can get from the air, or we can get from the co-op, I'm at 97.5% of my plant. My other with just 4 elements, my other 5 elements are going to make up 2% of my plant's dry matter weight. Okay? That's all I need to build structure. Is that physical part of the plant. What we see above ground, the root system below, is predominantly only 9 minerals. Now I still have a half of 1% down here. All right, what are those guys? Okay, let's go to this. Well, let's talk about this right now. Carbon. Where does carbon come from?
Yeah.
Okay, it's a gas, it's in the air. How does it get there?
Emission.
Emissions from humans,
Vehicles.
microbes. Okay, vehicles is carbon monoxide. This is carbon dioxide, yeah. Our lungs do a little different job than a combustion engine. However, you're right. So our carbon, which is just carbon, which is only half of this equation, is responsible for 45% of my plant's dry matter weight. Oxygen is the other half of that. So carbon and oxygen is 90% of my plant's dry matter weight. Now I can get oxygen from water, which is H2O. I can get it from CO2, carbon dioxide. All right? These guys put together the most definitive work on soil microorganisms and plant interaction. This study here done by these guys ranges from the late 1800s into the mid 1900s. And yes, these guys are Russians, and they have done the best biology and plant research to date on the planet. We didn't even have Americans contributing to this body of research until the late 40s and a few in the early 50s. I mean, we were the late comers to this knowledge and this research. Okay? The most important component of the soil atmosphere is carbon dioxide, which is the final decomposition product of organic matter. Okay? So, the intensity of the biochemical processes taking place in the soil can be judged by the amount of carbon dioxide released. What that basically is saying is, how many aerobic microbes do I have in the soil putting out carbon dioxide? They take in air, just like we do, and they kick out carbon dioxide, just like we do.
Blender.
Microbes. Plants take in carbon dioxide and kick off air. But that's the reality, is we're exchanging. We take what they give off and they take what we give off. But in the soil, you got to have your microbes there, your good microbes producing CO2, or you don't get plant growth. I can't get structure without carbon and oxygen. It's 90% of my plant. Okay? Everything that favors growth of microorganisms increases CO2. Okay, so my microbes are producing my plant structure through a gas. Same as us. When we exhale, we're producing CO2. It helps plants. So here we go. Hydrogen, carbon, these are my big numbers, getting up to my 95% of my plant material. My other half of my plant's dry matter weight is trace elements, my micronutrients. So, obviously, these guys are not structural components. Okay, so let's go back to our tractor scenario. I got a 50,000 pound tractor sitting out there. How far does it go without fuel? Nowhere. And so I have minerals that build plant structure. These types of minerals run plant functions. And how do we farm today, Ed? How does everybody usually farm today?
Round.
Tractor with
What kind of minerals do they usually buy?
NPK,
NPK.
nitrogen, phosphorus.
Yeah, the big thing at the co-ops is sell NPK, tons and tons and tons of NPK. And that builds structure, but it doesn't create plant function. And so just because I've got a big tractor out there doesn't mean I'm going to get any work out of it. It means I have to make that thing operate. I've got to have a fuel source. And this is what these type of trace minerals are doing. Remember, we talked about how everything gets transformed. Okay, we have an enzyme here, and then we have activators. And predominantly my trace elements are my activator. My enzymes aren't going to get any work done until I have a trace element that kicks them and lets them become functional. Okay? And so that's the real critical thing here, is having the adequate trace elements so that the enzymes in the microbes, the enzymes in the plants do their job and put nutrition together. So if I don't have all these trace elements out there, one is I'm not going to utilize my NPK well, because NPK has to go from its elemental form into compounds, into tissue, into plant structure. It's got to get changed in all these different ways by enzymes to become useful. Well, if I don't have trace elements activating my enzymes, I'm not going to get good use out of my NP and K fertilizer. I've got to convert it into different compounds through enzymes. So right here, when we look at soil fertility, it's the balance between elements. It's not just that I've got a lot of one element, I've got all of them that I need. And all these minerals either help or hinder each other. So Mike, when you've got all this figured out, you let me know, will you? Okay? Because they're all working with each other. And the other thing that's really important to remember is my phosphate doesn't change into all of its forms without help from lots and lots and lots and lots of other minerals. We often think, well, if I just put out nitrogen in my field, magically, I start with nitrogen here, and I get a protein here. And somehow, after dark, the nitrogen fairy comes out and does all of his magic while we're sleeping. So how does my nitrogen change from this form through thousands of different operations into all of these different compounds? All of it's done by enzymes and cofactors that activate the enzymes. So if I ever want my nitrogen to become real protein and not a screwed up protein, a functional protein, it's got to go from here all the way to the other end. So what happens if I'm missing a mineral right here?
It's not going to get there.
It's not going to get there. I'm going to get a fractionated functional amino acid. And you know what your bird's going to do with that? Nothing. You go, I can't use this. You know? I can't do anything with this. So it will show up, but it's not functional.
So if I've got a bad chicken here, it's the farmer's fault.
That's what I'm telling you.
So if you put nitrogen on, you get good protein and you got good soil, right?
You've got part of the system working good. You do. And so, but when you think about this, I mean, maintaining all the bird's tissue, okay? All this stuff is protein based. Protein is a big factor in this stuff. And so all of these minerals, it's like phosphate, your potassium, your calcium, your magnesium, all of these things get changed hundreds and thousands of times into different compounds. And if I have something in this chain interrupting, I don't get this done. And that's why the insect goes, or the pathogen goes, oh, guess what? This is incomplete. I can eat this stuff. I can attack the plant. Because a pathogen cannot eat any end product. I can't eat a protein, I can't eat a fat, I can't eat an oil, I can't eat my carbohydrates that are all put together properly. That is not my food. This is human food and poultry food and hog food. This is pathogen food, anything short of this side of the equation. This is negative and this is positive. Okay? If I can't get all these compounds into good, complete substances, they're not usable. And so our farms, the co-ops say NPK, NPK, NPK. Well, when we look at a soil report, predominantly what's missing is not NPK, it's the trace minerals. And the co-ops say, well, you don't need those. You know, maybe one.
They don't even check.
Yeah, it's like, let's not bother.
Most of the soil samples don't even have them on there.
I don't even check them. And the problem is my plant is not designed to do all this at the night fairy magic nitrogen fixer. It doesn't work. And so I've got to have all of my minerals to do this. My soil properties, as much air as I've got water, I've got mostly mineral, and I've got to have some organic matter. So when we look at this, my water, 89% oxygen, 11% hydrogen. My air is 78% nitrogen, 21% oxygen, and we have this much nitrogen over our fields. We have 35,000 pounds of nitrogen above every acre. And then we buy nitrogen from the co-ops, because we haven't figured out very well how to harvest this. But there's microbes that do this very efficiently. Don't we, Ed? Sometimes too efficiently. Okay, organic matter comes from dead organisms, nutrients. It provides the dead organisms, the nutrients, the energy is 50% carbon. Our organisms here are plants, animals, and our biology. Okay? So we got to have these components in our soil. Now, Cornelius, what would you say is the most important mineral to grow plants with?
I'm not a farmer, I don't know.
Nitrogen.
Okay, everybody says you got to have tons of nitrogen. So let's go back here for just a second. Okay? Carbon, oxygen, nitrogen's way down the list. So, if I want to grow plants, what's my most important element? Carbon and oxygen, CO2. So, have you guys ever caught the co-op sneaking in CO2 after dark? They sell it in trucks, you know.
That's what they're doing.
That's what they're doing. There are no CO2 trucks, okay? That's the problem, CO2. They don't deliver it, okay? And if we destroy that beneficial population in our soil, we aren't making it. And so as a plant, there are indicators that plant roots not only release but actively absorb CO2. See, we were told before by the same guys who sell NPK that occasionally a plant will take up a little CO2 from the leaves through the stomata. Well, now we learn from the Russians, who keep screwing with our elections, that the root systems down here take up CO2 as well. Because the microbes down here in the soil are producing CO2, and the plant's taking up this CO2 over and over and over again. And so if we don't have a healthy microbial system, we're not going to grow plant structure. We're not going to get good yields. Okay? That's just one critical fact here on how plants put things together. Okay? Now, this is just a fascinating thing on what plants actually do with this stuff. Okay?